I'd like to jump.
I would.
We'll raise our bet.
Servers. We get like,
I highly
can you
doubt
watch
it.
it from?
I don't know. Can you? Do they have internet in Mexico? Inverse variation. We talked somewhat about this, I think, at the beginning of this year when we finished the 7th grade book. What was the deal with inverse variation? Do you remember? We did do a lot of this actually. You want me to go look and see? I can tell you exactly when we did it actually.
Lesson
Yeah.
99 last year.
All right. Well, I won't go back there. Lesson 99 last year or this year?
Last year.
We didn't do last year's book.
Seventh grade, you know?
Faith
I
memorized
wrote
those.
it down.
You
That
wrote it
is-
down?
That is really strange, Faith.
I write myself down too.
Remember, we've got direct variation and we've got inverse variation. Direct variation is as one thing goes up, the other thing goes up. I mean, like your salary, if you're getting paid an hourly wage, the more you work, the more you get. Inverse variation is the reverse of that, and it is as one goes up, one, God bless you, goes up, the other goes down. An example of that would be your speed compared to how long it takes you to go somewhere. The faster you go to get somewhere, the shorter amount of time. So that's inverse variation. But the little inverse variation formula you need to remember is, somebody, Faith, what is it? Y equals K over X. Y equals K over X. I will highlight that. This is kind of what you need to remember about that. Now, as a side note, again, let's go back and just think about direct variation. And I'll write it really small so you don't think it's that important. Direct variation, the little equation was y equals k times x, where this k was that constant of variation. Like I said, if you're talking about making money at a job, k would be like the $8 an hour or $15 an hour at 4 years that you'll be making as minimum wage. You know, whatever, however many hours you work, you get multiplied by 8, and that gets you y. If you're doing a little table, it would look like this. You know, if you work no hours, you make you make no dollars. If you work 1 hour, you get $8. If you work 3 hours, you get $24. It's a nice straight proportional. Direct variation is proportional line. You get all that. If you remember about inverse variation, one of the things we talked. Oh, did I do something wrong?
For the formula for the big one, you have to divide you line.
Oh, yeah. Why did I do that? It's the same.
Yeah, that's fine.
Why did somebody not fix me?
I
that
tried.
before? Oh, you did.
I wasn't paying attention.
I was just on some sort of a roll. Don't worry, it can be fixed. I will fix it right now. I don't know why I did that. I feel bad about that. Not really bad, but kind of bad. Oh wait, what just happened? Still feel bad about it. Alright. Oh, that's not even blue. Second. Let's do this right. If you remember, by the way, I think we talked about this. An example of this is like this. If two people can paint the house in 20 days, how long would it take 8 people? Question mark, question mark, question mark. And one of the things we talked about with this was if I made a table of x and y, and if x is, which one is x? The days? No. X is the number of people. 8 people, oh, I'm sorry, 2 people. Let's go with what I know first. 2 people take 20 days. if you had 8 people, how long would that take? And do you remember how we did that?
We did something.
Multiply.
When you have inverse variation, Abram, what?
You multiply it to see the number.
Whatever these two times themselves give you, every column would have to give you that same number. So if it was 8 people, it would only take 5 days. Notice how as the more people, this goes down. If you had 10 people, it would only take you 4 days. If you had 40 people, it would take you 1 day. Now that's granted that you can keep everything there. And then, children, we also did this. Notice if I did the graph of this, it's just a nice linear equation. Remember, it started at the origin and 1, 8, 3, 24 was just a line that shot up like that. What does the graph of inverse variation look like? See how quickly you forget this? I know I did this. Check this out. I probably shouldn't have picked such big numbers there, but we'll go with it here. First of all, well, let's do this. 2 people would take 20. So here's 2. And then I have to go up 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 2 people take 20. 4 people would take how long?
40.
No, 10. So 1, 2, 3,
I knew
4.
that.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 people would take 8. 1, 2, 3, 4, 5, 6, 7, 8. What would be my next multiple 40 I could use? 8 took 5, right? 5, 6, 7, 8, 1, 2, 3, 4, 5. 40 people, which would be way out here. Let me extend my little. 40 people took 1. What if I had 400 people?
We'll get real close to the
2.4 hours. Something like that.
1 hour.
2.4 hours. It took 40 people 1 hour. If you have 400, it's not going to take 2 hours.
When you multiply that.
It took 1 day.
I thought it was a dish.
Know
Yeah,
this.
I know, but if you don't know how much would it take?
What did I do?
Point
What did I
10.
do to if I had this, what did I do? What did I do here to get that? I multiplied by whatever number gives me that. So the question you have to ask yourself is 400 times what number would give you 40? Well, you'd have to divide by 400. Divide by 400, it would take you 1/10 of an hour if you had 400. So the line of this looks like, and then if you had 0 people working,
It would never get.
you would never get it done. So there's no way this ever crosses the y-axis here, and there's no way it gets to the x-axis here. You end up with, this is the graph of inverse variation. You get this little slopey looking little line that does this. And it never, ever, ever gets to the axis, because you can't. You can't have 0 people working to get you nothing, or to get you some sort of a job done. Nor can a job be done instantaneously, no matter how many people you have doing it. You could have 10 million people, it's still going to take you a fraction of something. So it'll approach those axes, but never ever get there. So, if you want to know what your constant is here, you'd have to plug your numbers in here. Y was 40. 40 equaled k over x. X was, what was our x? It didn't matter. I mean, it would be x was 2, and then k just, ends up being whatever that thing is. You'd always divide it by that. This times that thing gives you that. Now, what you need to know also on this is this. There's a little formula that says this. Where is it at? Where is it at? Somebody help me. Where am I at? I lost my page. Here it is. It's called the product rule. For inverse variation, is the product rule. And what that product rule says is this, that x1 times y1, x1 times y1 has to equal x2 times y2. So you go, huh? Well, that means if you're given 2 points, let's say you're given 3, 8, and then you're given, I don't know, 6 comma, you don't know. You can take those points, plug it into this little formula, which is really the same thing we just did. Plug it into this formula and get your answer. So it would look like this. You can find that missing letter by doing 3 times 8, which is 24, and that equals 6 times what number there? 24 equals 6y, so y sub 2 would equal 4. It's really the same thing we did on that little table thing, except it's written out in a formula. So this is important to know. If they ever tell you something's inversely proportional, you're going to think this. And you just got to look at what things are inversely proportional. For example, I know you're going to ask, look at page 421. Look at page 421. Are you at page 421? Look at practice letter C. If y varies inversely as x, and y equals 3.5 when x equals 20, find x when y equals 10. If you're doing that, the first thing you observe is that it is inverse variation. And you probably want to jot down the little rule that says x1, y1 equals x2, y2. And then you need to plug in the numbers that they give you. Because it's not always going to be nice and clean like we see. It says when y varies inversely with x, y is 3.5 when x is 20. Y is 3.5 when x is 20. Find, what did it say there? Find x when y is 10. So you know y is 10, you don't know what this is. It's a pretty simple little equation. 20 and these 2 times themselves is
70.
70 equals x sub 2, or 10 times x sub 2, so you divide by 10. Divide by 10, x sub 2 equals 7.
Wouldn't it just, never mind,
Could be. I've had made some mistakes. I'm kind of floundering. Wait, is there a question on it? What about letter E? Let's look at a story problem there. Sierra found an inverse relationship between her hourly pay rate and the number of hours she must work to earn a set amount. If she works 7 hours for $8 an hour, how long will she work at $10 an hour to earn the same amount? So basically, you just have to put x's and y's in there. You probably could look at it and tell you the answer, but you're just going to say, again, you've got x1, y1, and that has to equal x2, y2. What 2 do they group together? You get 7 hours at $8 an hour. 7 hours at $8 an hour is inversely proportional to whatever for $10 an hour. And it doesn't matter really which one you call which, but let's put it out there. So 8 times 7 is 56, and that equals 10x squared. Divide by 10, divide by 10. 5.6 what? Hours. Hours. Unless she gets that $15 minimum wage that everybody's going to get. You really, if I were you guys, I wouldn't even go to school. By the time you get out of high school, you're going to be making, what's $15 an hour? What is that? What is that a week? 15 times 40. You're making $600 a week times 50 weeks. You're making 30 grand just walking out of, why pay $40,000 to go to college when you can make 30 grand just coming out of high school?
Because
And that's just the bare minimum. As soon as you get a couple of years experience, you're probably up into 60 grand right there already.
I don't have
Talk to me. Are you not Democratic or are you Republican?
Easy money.
I don't really know. I don't have a political view.
Well, we. If you work at McDonald's, you best be getting.
See, the only